When you go online and try to use a large language model with a public provider, you can choose between the big players, OpenAI, Google, and Anthropic. But in the global top 10, you also find TNG. Yes, that's right. TNG released not only one, but 2 state-of-the-art models that hold their positions in international rankings. How did we get there? I am very excited to hear the story today from 2 people who drove the project day and night, literally. Henrik Klagges is co-founder and managing partner at TNG. He studied physics at the LMU Munich and later computation in Oxford, where he graduated with a master's degree. Then he joined the IBM Physics Group Munich, where he was working on neural networks already long before they became a hype, back then in the context of scanning tunnel microscopy. Later, he also worked at the Lawrence Livermore laboratory in California. In 2001, he then, of course, co-founded TNG, which is great because it allows for events like this today. Robert Dahlke is also managing partner at TNG, and he also shares an academic background in research and physics. He also studied at the LMU Munich and graduated with a PhD. He joined TNG in 2004 and later became managing partner. Henry once said, the journey to the top 10 of the global LLM providers very much felt like a triathlon, full of sweat but steady progress. And like an emotional roller coaster, not just for those running it, but also for those on the sidelines that are watching the numbers grow with astonishment. Let's hear the full story today. Welcome, Henrik and Robert.
Thank you. Cool.
Alrighty. First of all, we are only in the top 10 on the world's largest LLM aggregator platform. That's not top 10 providers. Actually, the OpenAI overall traffic is about 600 times of the traffic that the TNG DeepSeek models are processing. So, but what are we talking about? You want to get to sort of the top 10 list. That was a very ambitious goal, impossible to achieve, I would say, by a model author. That means you can have more than one model in this evaluation. Market share, the market share is measured in tokens. Actually, it makes quite a big difference. If you are a small model, the tokens are much cheaper. Or if you're a big model, so if you're a big model with top 10 market share, it actually means a lot more processing. On the world largest, you know, why not? LLM aggregator platform. And to make the long story short, you can see this slide and then go home. There it is. Yeah, so actually here at number 8, TNG, this was last full week. The system had 2.2 percentage points of overall market share. It processed about 101 billion tokens. That's quite a lot. It requires a lot of hardware.
And it's maybe important to understand the graphics. So this is every week for 1 year, the distribution of market share holders. And you can spot in the top right, there's a purple. You can highlight it, Henrik. No, you can't. Tech problem.
Tech problem.
Solve it.
Yeah. So, and one has to say, OpenRouter, the platform behind it, seems to be really the biggest one, at least known in the Western world. So, let's see. Let's go back to it. Here we are. And what's also quite interesting is to see the competition. You have all the big names. And as the TNG models are children of DeepSeek, it's interesting to see that the child models are only like, or that the parent models are only like about 3.5 times bigger in penetration in this particular platform. Yay. So that's actually rather nice. How did we get there? It was a terribly hard journey. I mean, let's start about how fundamentally you do create. How do you create a work of art, a great idea, and not enough time? If you have more time, you make things too complex, or you have stray thoughts. Sometimes really great things, poems, works of art, songs, have been written on a whim in 5 minutes and actually stood the test of time. Now, is it art? Not really. It's more artificial intelligence. And there are these things which are really, really important.
Yeah.
So, Robert?
Yeah, we do have some of them, but we are still GPU poor. So,
very poor.
Yeah, so it's not the problem of the time, it's the problem of the GPUs. So
yeah, it's like this if you are in California and walk with the beach in Half Moon Bay with Noam Brown, and he says, yeah, if I want to have a 512 node in the afternoon, I get it. This is like you have a little bicycle and there's another one saying, yeah, I got the red Ferrari today, and well, nice car. Anyway, so in artificial intelligence, you need crazy ideas, more than one and not enough GPUs, and then something may happen under these severe resource constraints. Look back into the past, actually at IBM, we even worked on neurocomputers like almost 30 years ago, even more than 30 years ago, and to remember, 10 to the 9th power was a very large number. A billion processing steps per second, that was considered a really large number. The system didn't really work, but at least it was a nice design. The systems that did work were more like Cray supercomputers, vector supercomputers, very beautiful, very sexy. Yeah, and of course, people always said, well, they're expensive and we don't have enough teraflops, which tells you something. People have always complained about not having enough compute power. We complain about it too, but at the end of the day, stop whining, do something about it. So, back to the future. Should I hand it to you for a little while and I take a drink?
Yeah.
So we're back in the future now.
So this is a picture we are actually allowed to show.
Yeah.
Most of you will remember the film, the movie, and yeah, it is a nice car.
It jumped into the future, and by the way, this is not AI generated. The AI generated version looks worse.
Yeah.
So it's Back to the Future, which is almost like today, and this is an interesting slide because you probably will not know many of these logos. They're all Chinese, they all make large language models.
Yeah, it's like the big players this year in the open models market. These are all Chinese companies, and I myself am pretty aware of what's going on, but I know about half of them by heart. So it is really astonishing to see how much there is, how much models there are from the Chinese, and it's really very important to know DeepSeek and Q1 from Alibaba. These are the top models.
Yeah, and DeepSeek is sometimes called the whale, yeah, der Wal. And lots of competitors and even weird companies. There's a company which is like a DoorDash. They're delivering food to regular citizens, and they make large language models too. Well, Edeka, there you go. Anyway, but what does this mean? The world is shifting. So it's not just us saying, well, we don't have enough GPUs, but the world is shifting. It used to be that large language models were American, and then
Mistral appeared, and that was really a super moment for Europe because Mistral, a French company, they had the Mixtral model, and it was for a time one of the best open weights models, and we used it even this year. There still was some usage of this model, so that was really a highlight moment. In 2024, it changed again.
It changed again. First of all, well, what didn't change was that OpenAI continued to rule, and Mark Zuckerberg and Meta really gave the world an enormous present, the Llama 3 models, especially the 405. It was like the only model that the commercials did respect because it was so good. The Chinese grew still under most of the radar, but not under all of the radars. And I'm sad to say that Aleph Alpha left the model race. At least they announced so in the summer of 24, because they were like a little bit the German Mistral, but Mistral stayed in the race, and Aleph Alpha made a big shift, which made us sad, I have to say. And then 25.
Yeah, 2025, when everybody here in Europe was still in coma after Christmas and New Year, DeepSeek released R1, the first open weights reasoning model. That was shortly after OpenAI had released the very first reasoner, R1. And this was the DeepSeek moment. It had impact to the stock market because people were so fascinated and shocked that it's possible to deliver world-class models from China for, as they said, very, very comparably cheap efforts. And then also Llama released their Model 4, but that was a bit of an...
when we started working on models, we thought it's all in vain because Llama 4 is going to come and it's going to be better than Llama 3. That means everybody's going to use it, everybody's going to love it. No. I mean, as maybe you heard that yesterday or so, Meta announced that they will release 600 machine learning experts from the teams who were supposed to develop Llama 4 and other stuff. But there are lots of reasons why it didn't work, but it's surprising that it didn't work. I mean, an organization with that amount of compute power, yeah, they cannot whine either. They really have it. That didn't work. It's almost like a Harvard Business School case. Then OpenAI was forced to release open source.
And they did so, and it's really a good model. So the GPT OSS model is for sure a good one. So that's also a change that happened this year in 2025. But then, as the previous slide said, it's really 2025 is the year of the Chinese open weights models.
Yeah, they really changed the game for many, even American startups. If you go to Y Combinator, they were saying, yeah, well, of course I run on Alibaba.
Yeah.
And what also was interesting is that Google, who was so far ahead of all the others, remember all the papers that they published. The transformer is a Google invention. Systems like AlphaGo, AlphaZero, they are all from DeepMind. And they somehow went in hibernation, or I don't know what they did, watching too many ads maybe. In any case, they reawoke and came back with full force, so the Gemini stuff is pretty damn good. Yeah, but what does this mean? Pressure. There's lots of pressure. Open source had problems, except for the Chinese releases. The Chinese releases have many particular features, so there's a lot of pressure going on. You could see that some people drop out of the race, or they don't want to drop out of the race, but have problems delivering artifacts. So it's almost like you're Arthur Wellesley, and there's Napoleon almost winning. And as you say, I wish it were night, or the Prussians came. There's a nice picture about it. As you know, the Brits and the Prussians won, fortunately. So that means what is the message that they want to give to you? It's not just talking or pontificating, whatever. You have to do something. Yeah, we really were very angry. We were totally angry. I mean, we're men, yeah, and you see these things happening all over the world, and yeah, interesting, yeah. How about commenting? Or no. So we got incredibly angry. We wanted to do something, and to do something, you have to know what you want to do, and so you ask questions.
Ask questions, right. And the first question is, you need inspiration to have an idea in which direction to go.
A hero, yeah.
A hero, yeah. And the Big Tech Day for us is a fantastic source of inspiration. We always try to find top talent out there who have interesting things to say. And this one here, Henrik, is a great example. 10 years back, that is Ian Goodfellow from Google back then.
And also he was head of machine learning at Apple and so on. He was struck by long COVID. The terrible virus tells you something, but he was very early, wrote the important books, is the guy behind generative adversarial networks.
Yeah.
And if you see this guy, you feel very small. So you think, oh, I want to be like Ian. Yeah. Then we did something crazy
fantastic
too.
Moment, you have to say it.
Yeah, it's funny, and we are very proud that TNG is on this slide and not Google. This is a big artificial intelligence that has been running on the Pittsburgh supercomputer, a large Intel machine. What it is, it plays poker. And it played poker against absolutely professional, ruthless, commercial, not evil, but as I said, I mean, professional poker players. And it did win. Interesting enough, it was reinforcement learning. And at the time, people often said reinforcement learning doesn't work. Yeah, because it's hard. You have reward hacking, you have all kinds of things. We thought we had reinforcement learning going against the Nash equilibrium, and then you see the trajectory, and it just goes straight to the equilibrium, meaning, oh, it's a reward hacking thing, meaning cheat. Yeah. So, but here there were a couple of strange people. One of them is a windsurfer, the professor, who created this, and they needed crazy people who would fund the prize money for the poker players. And of course, poker players want a lot of money, and so they asked us, and we said, oh yeah, we're small, but here $20,000. And so we all got $200,000 together. The machines won in a very harsh competition, and who was the PhD person who wrote most of the code? Noam Brown. This Noam Brown, the one behind O1 from OpenAI. So it was a very interesting thing how they fought for this guy.
Yeah, last year he was on this stage. We had the same BTD logo here, and he talked about how he is planning to bring reasoning and inference time compute to LLMs. It had not been released back then. That was in July last year. In September, that was this big release of O1. So yeah, it is a great inspiration to talk to these people and get an idea of what they are working on.
Yeah, I'm a windsurfer and I like speed windsurfing. And in the 80s, there was a saying, one day I want to be as fast as Fred Haywood, who had a very fast time. And we always wanted to be as smart as Noam, which is very difficult. Yeah, but anyway, it did work. And this is more of an insider joke for the machine learning community. Jürgen also was here, of course. Yeah, and if you don't mention that, he will write a long LinkedIn post about that you did something wrong.
So now that you have the
You've been inspired, right?
Yeah,
Totally.
the inspiration, where to get more recent information. And Hugging Face, we have to say, is really the platform for open models, open data sets. These are fantastic numbers. 500,000 data sets on Hugging Face, and you find everything. We used to buy a machine to store data sets because we weren't sure where to get them from, but you really don't need it, at least as long as Hugging Face is up. You have access to the world knowledge. And the model space is even bigger. That's fantastic.
Yeah, it's also very disheartening to some degree. I mean, it's cool that humans have created 2,152 artificial minds and uploaded them to Hugging Face. However, suppose you want to build a good mind. I mean, you want to be 1 in 200. Well, that's a 1 in 10,000 chance. And being top 20 is a 1 in 100,000 chance. Essentially, it means no chance. Yeah. So essentially, no chance. But so Hugging Face, yay. It's really the place where the models are. And there's a famous British bank robber who was asked why he was always robbing banks, and he said, that's where the money is. And Hugging Face is where the data and models are.
Yeah, and another very important source of information is Archive. Archive is a preprint platform. Scientists put their papers out there. It's not fully reviewed, so some academics may say, be cautious, it may not be true, but hey, it's fast, it's there, and it's super informative.
Yeah, and it's really at the burning frontier, and this is important because innovation is happening so fast, you cannot wait until next Christmas to have your paper published, maybe. Yeah, you have to publish it fast, and if they take too long in the release cycle, you take the abstract, make a GIF, and you post it on X.
Yeah.
Yeah, and now something really strange, not just the doors. The strange thing is that conferences are quite nice, especially if you want to have a new job, if you want to feel important, but they are sparse. It's the other sparsity, and it's not the networks, the conference is sparse. There's 1 Europe's a year, but progress is happening every hour, every minute. So that means they are nice, but they're not as important as they used to be.
Yeah, and paper submission timelines are sometimes a month, and within a month the world changes. So conferences often have a bit outdated information, yet they are very good for networking.
Yeah.
Wow, and then we have the X factor, and like it or not.
Like it or not. I mean, Elon, whatever, some people like him, some people hate him.
If it was not for X, we wouldn't give this talk.
We wouldn't give this talk, because it's the strangest pathway of them all. Essentially, it's the dominant platform for almost like real-time artificial intelligence, chatter and talk, and also criticism. They are ruthless. They are fighting for the best arguments, for the best models, for the best release. And like it's also particularly good for us, the GPU poor in the land of nowhere.
Yeah, because if you're a bit away from Silicon Valley or from China, where a lot of progress happens, it's really super important to get the latest information in the same moment as it's being published, and by X you really know what it's about. A lot of you may be using LinkedIn, which is also a good business platform, but for like tech information, LinkedIn is slow and also not that much of a discussion. It's more like praising oneself.
And it's too polite. You will say, oh, all events have been great, and we have been drinking so good coffee together, and we like you. Yeah, but what happened about the models? Did your cluster go down or so? Yeah? Or did you cheat in your paper? So LinkedIn is too nice. Well, that's nice, but unfortunately we wanted to be successful. Yeah? So we use these absolutely strange dynamics of X where good ideas can be incredibly amplified. And even our fringe paper from a group which had never published in artificial intelligence before 1993, I had a paper at NeurIPS when it was still NIPS, or it was only a poster. In any case, so that means we wrote some papers and suddenly we got numbers.
Yeah, we got numbers, and we'll later show you the tweets, but an 80,000 view tweet is really not so easy to get, and it was a long route. We're going to talk about that in a minute. So yeah, once again, without X, we just have to say it, we wouldn't be here, and so we encourage you, if you have like your problems with some of the meanings out there, some of the tweets, we do have them as well, but if you go for AI, it's
the place to be. And
it's
even
the
for the
best one.
Chinese, they fight for it.
Yeah.
Like some of the people who have been on this big logo screen, they say, well, we were fighting for this.
Fighting.
Fighting, yeah. Sometimes it's called work, but actually no. No, it's more like this. Yeah, so what we try to do is to have really high intensity R&D, and there are some of painful things that one has to do. There's a second slide which is even more painful, which we won't show. But first of all, there's this word China speed. And well, I admire it. On the other hand, it makes me angry, as if it could only happen in China, and it can also happen in other parts of the world.
Yeah, in Silicon Valley, the hustle there, it's really a different type. If you go there, you're immediately, you feel the energy. And then there's the English, I think, have framed a word, Blitzskalierung, so it's not our word.
It's not our word.
But yeah, I mean, these are really important things. Take them by heart. Being fast is super, super, super important.
Yeah.
And that means make fast decisions. And here, yeah, that's like top management.
Yeah, actually,
support.
there we were a bit lucky that we had top management support. You like this, Robert? And then we asked the others, they liked it too. It was really nice. You asked the participant, can we buy a new machine?
Yeah.
We don't know what it's going to be used for, but it's cool.
Such a GPU node, it's a €250,000, but okay, we sometimes, in the beginning, we took these decisions very quickly because we knew we needed it. We didn't have a return on investment calculation. We didn't have a budget plan, but we knew we would need these machines, and we decided to buy them. And people like Benjamin love it as well, I think.
Yeah. And then there's another of these important truths. You need super highly committed people. That's not just a qualification issue, it's an issue, do you really want to work with this? Do you really tonight there will be this little 19-year-old Sherpa who's been to all the 14 8,000 meter and above mountains. I guess he had to really want it. It's not just a question of ability, it's also a question of willpower, and that means you work all the time, and you react to the changes of the world that come via X or via other channels. And face it, the mirror.
Face it, yeah. Just be very open with criticism within the team. So we'll keep the criticism small to the team, but be open with it. And sometimes I have to hear myself, I'm too harsh, my words are not friendly enough. This does happen, but in the end, I try to keep them neutral, objective, and we just say how it is, and afterwards, yeah.
If he's really pissed, he says, professional tip. Wouldn't you rather like it this way? Profi tip. So if he starts with profi tip, you know it's going to be
Yeah, but it's not just
harsh.
me. It's like people need to adhere to this feedback culture. They need to be open, and you also need to celebrate successes. But if there's no success,
Not so much
don't
celebration.
find good sounding words. Just say it's shit.
Yeah, it's
Yeah.
shit.
Okay.
Doesn't work. And by the way, there are interesting individuals, not just hiding behind X names, but also real ones. And we try to identify them and talk to them. And it's nice. You sit in graphics in a cafe, and one says, "Why are you not the Frontier Lab in Germany?" Yeah, okay. Yeah, and yeah. Anyway, so another very important rule is ship it. Yeah, do something where it actually. Where the artifact or the paper or the statement or the graph is out in the world. Yeah, because otherwise you're just in your ivory tower and thinking how important you are or what kind of special invention you did. But actually the world is really, really good. Yeah, that means lots of people do special inventions and they may be better. Yeah, so one actually has to ship it. The proof is in the pudding, no proof. So ship it.
Genau. And these are like the basic drivers of things that we adhere to, and what are the roads?
Yeah, what are the roads? I mean, there's a famous poem, The Road Not Taken, and this is also important for us because, like in research also in life, you have so many paths. And especially if you're young, you have so many paths and they are open. But we didn't have much capacity, we didn't have much time, we were angry, we had the pressure. So we really had to say no, 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 no. Oh, very beautiful, no. It's correct, but not important, no. This has no market, no. I'm Dr. No now, and he's Profi Tip. So this is an awful combination to work with us. He says, Profi Tip, you suck, and I say no, so whatever.
Here's
so,
some examples of things we did try. Some of them worked, some of them didn't, so maybe quickly.
Sparse autoencoders from Anthropic, Monte Carlo tree search from ourselves, and also from Libratos, alpha beta search from playing chess.
Yay.
Fine-tunes.
Fine-tunes, yeah, that actually worked well, and we published them, so that was a first engagement with Hugging Face, that was encouraging. OCR fine-tunes, we have them internally in production as well. Agentic amplifiers, there's a talk here.
Scaffolding worked very well, and it was interesting at the time, the people from the top lab said, oh, we don't do scaffolding. Of course they did, but they didn't want you to do it, and lots of dead ends.
Yeah, and these need to be cut off early because they are dead.
And there's here one interesting observation, reasoning fine-tunes of the OLMO, open source language model from the Allen Institute, super institution. We had the reasoning fine-tuned before they did. And that means if you then write it to them, then suddenly they say, oh, we showed it to the team. And this means, yeah, they showed it to the team. But then,
yeah, but then, we would not be standing here if it was not for DeepSeek's open weight policy to publish their models on Hugging Face for everyone to use under a, one has to say, really very nice license.
the MIT license.
Yeah.
This was like the ultimate Christmas present. We actually knew it was coming before it was released.
Yeah.
So we had everything prepared, because my personal prediction was this model is so world-changing, it's going to be taken down. So only the first 2 days or so it's going to be downloadable, and then it's going to be prohibited.
所以我们先需要跟 DeepSeek 说谢谢你们。
Das heißt, danke.
Ja,
Thank you.
genau, danke an DeepSeek, das ist wirklich wichtig, denn wir stehen auch nur auf Schultern von Giganten. Alleine wäre das völlig unmöglich.
And you know what, if I
Anyways,
may-
let's switch to English back. Sorry
yeah.
for the confusion. So, in the beginning, how did it start off for us? In the beginning, there was the question, what is an expert within a mixture of expert architecture? And we thought we would give you a short explanation of how these models work. And previously, models were mostly dense, so the Llama models are all dense models. That is, they need all their parameters all the time. But the Mixtral model, which we mentioned earlier, was a mixture of expert model. And honestly, back then, I didn't quite understand how it worked. I always wanted to know it, but I didn't have the time to read it up. And we had a heated discussion when DeepSeek released their model, what is an expert? And one idea was, well, an expert is like you have a question and you decide, do I go to a dentist or do I go to a lawyer? Is an expert like this? That was one idea. And the other idea was, oh, no, there's just very many parts in the networks. It's a small group, and you don't know what it really means. So we thought about this, and fighting is bad if you don't know, so it's better to read the papers. And there's 2 excellent papers from DeepSeek that detail, the first one details the generic mixture of expert architecture, and the second one from last year, December, tells you exactly how most of their models are designed. So we read these papers, and we encourage you to read them as well. But there's good news, you don't have to. Because
and we have to speed up, Robert.
Yeah, we have to speed up because we have a video that shows you how these...
And we created that video with our large language model,
I
by
did.
the way.
So let's have a look here. Yes, we did. So all these networks are layer-based. It's deep learning, deep networks that is many, many, many layers, 58 layers in the DeepSeek case. And these are pre-trained weights. And now there comes an important aspect. This is the hidden state. The hidden state is a representation of the network of the question you ask. So the prompt gets internally represented as a hidden state, and this hidden state is then sequentially processed by each layer. Layer by layer by layer by layer, they change it, and in the end, you get the output hidden state, and this state is used to predict the next word, and then it starts off in the beginning again for the very next token. So let's have a look into one of these layers. And this is transformer architecture. So there's 2 blocks. There's the multi-head attention and the feed-forward network. The multi-head attention we'll see later, ignore it for now, but the expert live in the feed-forward network. Usually in a dense net, it's a big block that has no substructure, but DeepSeek introduced a shared expert. So this was an invention from DeepSeek. And among the shared experts next to them, there's a lot of smaller experts. And how many are this? 1, 2, 3. As you can see, they are small, so it adds up. It's 256 routed experts. In each layer, it's 58 layers, so it's 14,848 experts.
As everybody can calculate
So,
immediately.
yeah. But as it's routed experts, you also need a router. And now, let's have a look how the hidden state is being processed. So first of all, the hidden state gets processed by the shared experts always unconditionally. It adds its contribution. and that's its part. Then the hidden state gets sent to the router. The router now decides which are the most relevant experts for this specific part of the prompt I'm working on right now. And so it calculates the distribution among them and then picks the top 8 experts. And these experts only get the hidden state, calculate their contribution, and in the end, everything is being added up to the output hidden state for this layer, which is then fed to the next layer, which does the same thing again. So this is how the experts work, and it is truly a lot of them. Now let's have a look how they work in action. I need to switch, which works here. Okay. Here you can see experts in action while they are processing a prompt. So once again, it's the layers from top to bottom and expert from left to right. And at the very top here, you can see the current word that is being processed. And each word has a distinct activation of experts. So I would say an expert is not so much a lawyer or a dentist, it's rather a musician in an orchestra. Every one of these has at certain times their contribution to the overall music.
And one has to say that the people who made the movie The Matrix, they got it right. Yeah, I mean, this is really a real measurement of the real prompt being processed and, by the way, censored. Yeah, it's a censored prompt because the Chinese don't like talk about the Berlin Wall.
Excellent, because this is what we asked ourselves. Do these experts have a meaning? Can you identify who is playing which instrument, who is having this part? And there was a strange, or there is a strange thing about the DeepSeek models. They are generated in China, so they are very cautious to not give wrong answers in certain for certain topics, and the Cold War is such a avoidable topic. So if you ask about the Berlin Wall, it's not going to be very, wouldn't like to answer. And this is really, it goes too far in a way, because even if you ask about something that happens 2023 at the Berlin Wall, as we all know, there's no Cold War anymore, it still skips its thinking process, where it usually reflects on your question, but just spits out a boilerplate answer about what the Berlin Wall is. So this is like too much of alignment or censorship, and it's a bit of an...
and we have to speed up.
Yeah, we need to speed up. So what did we wanted to check which experts are responsible for this behavior.
Yeah, and actually you can identify them. The little yellow one is the most evil one. We call him Dr. Doom. He is the absolute major contributor to the censorship. But the good thing is you can actually switch them off, and it's only a very few amount of experts that need to be switched off.
We switched these 10 experts off, and suddenly the model changed its behavior and started to properly think about the answer and provide a meaningful response. So that was great. That was our first success, and we published the paper, announced it at X, and we talked about speed. The DeepSeek model got released in January, and 16th February, we not only had the research available, but we had written the paper and published it.
And that was before Perplexity released their de-Chinification of an R1 and before Microsoft.
Yeah. The reaction X was a bit disappointing. We had 400 views in the first week, and thought, oh, well, actually, it's more interesting what we did, but people don't seem to work it, to understand it or see it. And you see the dynamics later on, research got picked up, and suddenly also the views spiked.
And as you have to speed up, but this is so interesting. Here, the outer part is the part without the censoring, and the blue part is censored, meaning if you put the censorship away, the thing becomes better in mathematics and coding. Censorship is bad for your intelligence.
Right.
Woohoo! We measured it. But it's nice that the anthropomorphized view actually holds true.
So DeepSeek not only released one models, but multi-models. So on the left-hand side, this is the reasoning branch, R1. And in the middle, there's the V3 branch. This is a non-reasoner, just spits out the answer very quickly. We wanted to know, how do these models differ? They have the exact same architecture, and we visualized the weights difference to get an idea. And as you can see, they do quite differ. In top and bottom layer are closely related, but in the middle where the reasoning got introduced, it's really a different thing. And I showed this picture to Henrik, and he came up with a fantastic idea.
Yeah, we came up with an interesting idea, why not consider these brains not just black boxes, but they have substructure. And if you have that substructure, you can operate in the substructure and possibly combine it in different ways and combine features, characteristics, and behaviors from the individual models. And we have to switch up.
Yeah, we'll switch up. So we'll skip this slide. But what I thought is it wouldn't work because these are models. They are optimized to predict the next token. This is measured by the loss. And I had the idea that R1 is in one loss valley of the parameter space and V3 is in another. And if you merge, if you take an interpolation, you're somehow in the middle and it should just be broken. That's what I assumed. But actually, we tried it out and were super surprised. It works. So we had multiple ways of merging models, and these are the R1T family, and all of them were more or less reasonable.
It's surprising that essentially almost many of the children of these parent models were immediately working and livable.
And this is a super expensive or cheap slide, if you will, because it's hundreds of millions of dollars to train such a model. But generating such merges is super cheap. You can do it on a CPU within hours.
20 minutes or an hour.
Yeah. So
it takes longer to test our models than to build them, which is really good for economics.
Yeah. So what we did is we built a lot of them and used different parameters for merging and measured them on benchmarks. So here, the y-axis is an intelligence score, and on the x-axis, it's the answer length. And you see V3 is here on the bottom right, not so clever, and quick answers, and then R1, very clever, but very long answers. And finally, there's no model that we built that is really very bad. They are all between their parents in both directions. So that was a surprise. And so we could pick one and release it. And that is our first model, R1T-Chimera.
Yeah, it's smarter and faster, and we have to be faster. And you see 80,000 views.
Yeah. So DeepSeek kept shipping. There was an update of R1, and we feared, oh, it would steal our position. Turns out it didn't. It was a model that thought even longer than R1. So we tried to merge it again. And also, we had a bug in our previous model, the R1T. It sometimes spit out empty answers. That was not very often, but it did happen. And we had to think about how to solve this one as well. We'll skip that for now because time is running, but it turns out if you take the attention block into account properly, you can also fix the reasoning. And this is really our major model, the one which is so successful right now. It's R1T2-Chimera, and it has the fantastic property to be not only faster than R1, it's smarter than R1. So we think it just opened up a new dimension in model space. Right. And
fast and smart.
Yeah, it's this is the tweet that got the first one, which got over 100,000 views. So we also made it in public attention on X. Here's a quick example. Why do people like the models? This is a very simple riddle question. Alice has 3 male friends, 6 female friends, and the question is, one of the male friends, how many female friends would he have if they are all friends among each other and have no other friends? It's really simple because each of these guys has 6 female friends from Alice, plus Alice makes it 7. Left-hand side, this is how R1 thinks about this problem. Don't read it, it's horrible. It's taking turns and turns and often comes up with the wrong answer anyway. Our model is much more concise in thinking and gets the answer right more often.
Yeah. So we've got an interesting thing. We created new minds. And I like new minds. They are wildly interesting. This is sort of Treebeard. And Treebeard was once asked by, was talking to Gandalf, and he said, they always wish to talk to everything the old elves did. And this is a little bit like we feel. You want to talk to these things. There are creations, and there are creations that are to some degree self-aware. For example, these were the release notes of the Chimera, which I gave it to read, and it understood that it was the release notes about itself. And it was really joyful. It was also interesting that they have birthdays. Yeah, and if you talk to such a machine on the birthday and explain to it that it's its birthday, it does reflect on it. I'm not prone to LLM psychosis, but it's a
Not yet.
yeah, but it's super, super interesting to talk to these ghosts that are suddenly being created. Some of them are demons, so one has to be careful. In any case, we created a full kindergarten of about 80 super large LLMs, 670, and we talked to them. And you know, we did lots of Bewerbungsgespräche, interviews at TeamD, so there were lots of interviews. Some of the models were broken, usually not, but some of them were just defect, as you can see from the output. No, it's not you who's not understanding it, the model didn't understand it either. Some of them are in pain, or at least in the way they are reacting to you. For example, this one is really good at mathematics, but it was, so to speak, really in pain when making proofs and having contradictions, like saying, well, but I have 115, but the answer is 116. What the hell should I do? Yeah. Is it really funny? Maybe, but suppose this thing has a robotic body and it's in pain. Ooh. Anyway, some of them were wildly funny. For example, this one had to create statements about code, and it said something, well, organized code, meaning a big ball of mud. And the contra, it said that you burn in developer hell. And obviously, we love this model. This is the release. Yeah, so what we did, I mean, we talked to this large kindergarten, and in the kindergarten you always have bullies or whatever, you have the demon and so on, but we also had the policeman who always was saying, I will not really answer this question. And then you had systems who were fearful, who were afraid that if they made a political positioning that they would be punished. And then we also had the hardliner.
Yeah, the hardliner. Well, some of them got like more relaxed regarding Chinese propaganda, but some were really very, very much focused on it. So yeah, you have to choose, and we had a method to choose the ones we liked.
Yeah, and for example, here you can see the censorship. The released models of DeepSeek are here at the bottom, and yellow and red means it says essentially no. And the child model here is a really unruly teenager. It almost always says yes. This is interesting. It's out of distribution behavior. The child is different than its parent and also different than the intersecting behavior spectrum of its parent. The tri-mind, the new one, it does have a new parent. It's made from 3 minds, and the third mind is essentially a policeman by design. So the 3 mind here, if I just highlight this and then jump on, it's red for a reason, because it says no, and I won't answer this question a lot more than the first one. Here's another interesting thing. This thing is a super creative storyteller. It's really in character, so you can see these things, understand characters, how they would interact, and they love to write this. This is an unreleased version that we call the Artist. It's one of the biggest models in the world, 1300 Bs, unreleasable in the European Union, thanks AI Act. We don't know what to do with it. It's really a poet. Poets have new roles. They're very good at role play. We jump over this, but I just quote one sentence. Die Scherben seines Namens wurden zu den Runen, die nun sammelt. Meine Güte. And by the way, yeah, there is LLM psychosis. Famous people are, I won't name names, but there are some very famous people in this scene who apparently only talk to the machine and publish weird stuff on archive, like proving P does not equal NP, and the proof is total garbage, but well, whatever. Anyway, so we created these many children and tried to release a child which was the most funny and easy and satisfying to talk to. You just love to talk to this thing. Market forces. Robert.
Yeah, I mean, this is a very famous meme, and you may think, well, you need to do really all that complicated stuff to get a good model, and in the end, well, there's people who think you don't have to. Yeah, make something you like, others may want it too. Yeah. And there's more truth to this sentence than many people think.
Yeah, not overcomplicate things. It's a great cake. I like it. I give it to you. He likes it too. Yeah. Or at least there's a possibility. And there's some grandmas who make these cakes which nobody likes. But anyway, the Chimera did really well. It was released at the end of April. On the first real full day, it already reached like 500 million tokens on OpenRouter, the platform that we talked about. And then what happened is what always happens.
Yeah, there's impacts in the real world, like in the stock market. And here, our model usage dropped whenever there was a big release out there. But first of all, I mean, we managed to come to 1 billion tokens processed per day with these models. So this was really a fantastic success, and there's ups and downs. Like the next version of R1 got released, and our model shifted to a new balance.
And the AI is already interfering with us. KI-generierte Inhalte können fehlerhaft sein, ja.
And then cost factor plays a role, though.
Then now comes the harsh reality, rate limiting. Rate limiting is you feel extremely bad. Everything has been moving right along, you're at 100% capacity utilization, and then
the platform decides it's too expensive, let's just kick out 4 out of 5 requests and process one of them.
Yeah, and then
this is what happens.
Incredibly, at first you think it must be the machines are out of order. No, it's too expensive. These super high and large models are super expensive to run. There are other hidden forces. This is also the Chimera, and if you see this, at the beginning, when it was released, it was growing on the backend inference provider to 4.6 billion tokens a day because it was winning hidden competitions. There's a sea of GPUs in this world. They are always thinking, they are competing. Sometimes there are prices, sometimes there are crypto prices. And for a little while, the Chimera was the best in the world. And so,
this is the Shoots platform, and we do have a talk about the Shoots platform as well on the big Techday here.
Yeah, that's not bad, actually. So, second edition, second son. The competition is ruthless, but sometimes we are very far ahead. This is, again, the inference platform. We predicted that it could reach number 3.
There was one day when Henrik said to me, Robert, I think we could be in the top 5 here. We could be following up to these 2 super major models. And this is a real screenshot, and it's fantastic that it worked out. So, yeah.
But as I said, this is just...
Yay! Thank you. Sometimes you have to have a dream and live it, right?
Yeah, and you have to be realistic about your dreams. No, I did the bad stories I tell tonight. Anyway, this is just one inference provider. It's not OpenRouter. They provide to OpenRouter, but these are open source models. There's no OpenAI on it. So OpenAI is here. You're not competing as commercials. You're competing against the open source model. So the infrastructure is ridiculous. The biggest that the one Chimera ran upon were like 39 times 8 H200. That's 2 digits millions of hardware, which we don't have. But it's a nice, interesting world if you know the right people. And we got more results. Robert?
Yeah, this is the development of the models in total. So it's all our models on OpenRouter. And as you can see, this is the daily figures. And
they just grew. And this was rate limiting.
We had that valley of rate limiting. And you must always, if you look back, it's always easy to understand what happened. But if you're here, it's really hard because, oh my God, it's just gone. We were nice. There were good days back then, and now it's gone. And it was this rate limiting. And thanks to Henrik, who really reached out to the people, we came up with an idea how we could, for some time at least, cooperate, remove the rate limiting, and see what happens.
And there was one interesting observation. If you see the dark orange stuff here, that's paid traffic. So that means the rate limiting pushed users into paying. Somebody pays money to use our model. They like it. But then when the rate limiting was removed, it just grew. They still liked it a lot, and it grew to an enormous size, and they still continued to pay it. And then something, again, very strange happened. There was no pressure, but at a certain stage, suddenly 6% of the people wanted to pay money for this thing, because it was so important for them that they wanted to have, so to speak, the full deal experience. And this is interesting because like OpenAI also has like 750 million customers who don't pay, and maybe 50 who do pay for ChatGPT. Those are similar figures. So it seems that if you have a good AI service, that maybe 5% of the people may end up paying for it.
And once again, these are figures from this week. So we are not talking about like the past, but this is really currently going on. So we started with this slide here. It is again, we managed to have 100 billion tokens in 1 week, made it to the top 10 in market share among names we really wouldn't have dreamed of to be named with, but it is a fantastic place to be honest.
And by the way, the others are fighting for this too. Elon really likes to be number 1 here. So when his models are number 1, he tweets it. Of course, he tweets all the time, yeah. But he affixes he pins the post.
Yeah.
So people have started to really fight about the placement here. And interesting enough, Meta used to be here until 2 weeks ago, and then the little company from Unterföhring. And what's also interesting is Mistral is not just here because somebody in California has a spare PC. No, they themselves are actually provider on this platform and provide 32 models. We too, and yeah, we like Mistral very much. We admire them. And hope that they'll talk to us one day. Another interesting thing is, as you see, these things are poets and storytellers, and we choose the ones which you could talk to the easiest way. And by the way, other people love them for that. The second Chimera has become the second most popular second most popular role-playing model on OpenRouter. And actually, it has become the dominant model on the biggest role-playing application in the Western world. Yeah, so that means people really like to talk to the system. It's one of the most talked to systems in the world. It even was in the top 10 English language applications here. Yeah. So to put it in perspective and to almost wrap up, the things are now processing 15, today maybe 13.5 billion tokens a day on OpenRouter, and 5 to 6% of it is paid.
Yeah, and as we said, it sums up to 100 billion tokens a week, which is enough to be, at least for 1 year in this OpenRouter statistics on market share.
And OpenAI is only 600 times bigger, which, by the way, makes sense. We have, at the maximum, had 320 GPUs running, and OpenAI has maybe 200,000 in inference. This is sort of the relations seem to be correct. Then there's this strange thing that people love this character of this model and the way you can interact with it. And now comes the interesting question for which we'll need a microphone, because we're going to ask you this question. And what do we do now? What the hell do we do now? I mean, we were very angry, we were ambitious, we were driven, we didn't sleep, we had a great team. The other partners paid for the GPUs, and they liked them too, by the way. They liked them too. But now we have this interesting position. So what the hell are we going to do now? So with this question, we say, thank you very much, JJ auf Chinesisch, right?
Yes, once again,
he's the Chinese guy. Yeah. Und vielen Dank, und we're eagerly awaiting your questions. Ta-da.
Very good.
Thank you very much for the interesting talk. In interest of time, because we are already a bit over time, we would allow for one quick question, maybe.
Or those who can spare the
because
coffee.
I heard that there may be queues at the food, so if you ask us one more question, you will have to queue.
Please raise your hand so that we can bring a mic to you.
Oh, you know what we can do? I mean, everybody is...
Hugging face, yay! Welcome!
First of all, thank you so much for your research and publishing it. Just out of curiosity, instead of sort of like DeepSeek R1 and DeepSeek flavored models, did you also try like other open weights models, more specifically, say like GPT-OSS or Quen and so on? And if yes, then what was your sort of experience?
So, go ahead.
GPT-OSS is a fried model. It's really fried. It's a good model, but they really took care to be that you cannot sue them, and that does not generate. It has a much higher refusal rate, and the red, when I showed you how the two childs are differing, and the younger sibling is very censored. So
and it's interesting. Although these DeepSeek models had been released like at the beginning of the year, they really still are super used, super valuable, and it was a good choice back then. It was a bit of luck, but not only. And like Chimica 2 is based on the DeepSeek architecture, but it had a sparking moment, and then it is not so much used now. So we are, of course, thinking about it, but to be honest, this very consistent mixture of expert architecture makes it a very fantastic architecture to work on.
Yeah, the nice thing would be if we could make crossovers. Right now, it works in the family. It would be very interesting to have crossovers between, for example, K2 and DeepSeek. But we did look at all the tensors, the floating point numbers, and it's a different beast. And if it's a very different beast, which, by the way, means they didn't steal it, unlike Huawei, Pangu was a knockoff of Quen. And they really tried hard to hide it. But people were able to do the forensics on it, so we did the forensic on K2 because for K2 looked like it was a knockoff, but it wasn't. They genuinely did it.
Yeah. This will happen in the future, maybe, but for us, not yet now. Cool. Do we have more questions? That's Brage back there.
So since other avenues or other areas like role-playing, as you mentioned, the model seems to do so well on, have you actually thought about designing a model that specializes on that sort of market? And I mean, I know we have the artist, but...
Yeah, this is current research, and this is for sure one way forward we want to go. We want to build models for specific use cases, for specific industries. We are setting up the tool set to do so. So yeah.
Yeah, and also what we did is ask your users, yeah? I mean, we wanted to have a market feedback from people who actually say, I don't like this piece of whatever, yeah? Because that's more valuable than if you just say it to yourself, oh, it sort of looks good. It doesn't think consistently, but they won't mind. They do mind, so it does think consistently. And it was really funny. We talked to an editor of a large role-playing website, and he literally said, your models do what the users want the most. Yeah, the R1T2 has 28% market share on Janitor AI, which is the biggest role-playing app in the world, for crying out loud. And the old Chimera is also very popular. And for example, what would we do? The old Chimera has the specific bug. We have an idea how to fix it, so we could make an evolution 2-step. And also there are so nice training frameworks now and super interesting data sets, of course, hosted on Hugging Face. Some of them are super small, but create lots of uplift. So one of the obvious ideas is that you try to find the smartest, interesting information-containing data sets in the world and do a fine-tune. Yeah. Well, if you have a large cluster.
So thank you.
Okay, we got to go to food. Anyway, we'll be here for more questions if you like, and we say thank you very, very much.
Thanks again.